Hey, Bogdan here. Welcome to another video. Linear functions made easy just for you. Did you know that first differences could be positive or negative? Does that matter at all? Sometimes you have them positive, other times you have first differences in negative. And let me show you what is the meaning behind. So in this beautiful example that you see, word problem. So this is a satellite transmits position data at the regular time interval. So that is the keyword, regular time intervals. So the data will be collected at one time, another time, but the differences between the time must be regular, which is constant. So that's the keyword. And they give you some numbers. At the time, t is equal 0 seconds, the height is 250 kilometers above the earth. And at the time 8 seconds, this is 218. So now we are lowering the altitude from 250 to 218. So there is decrease in height. And then with the following assumption that descent occurs at the constant rate, we have to build a table of values complete, which means we start at 0, finishing with 8. So you have to plug in the numbers in between. And based on the table of values, we have to determine the patterns using the first differences. So let's see how that is going to work for us. So what we know definitely that we have to create a complete table of values, right? And the equal time steps. So this is important for you to understand that the first column using the table of values has to change. The numbers, the entry data in the first column has to change continuously by the same amount. So equal time steps. So for example, from 0, when you go to 1, then you go to 2, you don't jump to 5. It's going to be no. You have to go to 3, 4, etc. Compute the first differences correctly. So the second entry minus the first, we'll show you momentarily. And we have to determine if the relationship is linear. So two variables are provided. The independent variable, well, it's going to be the first column, time measured in seconds. The second column, height measured in kilometers. So given the data, right, we can build at least those two rows using the table of values. Time on the left side, independent variable, height on the right side, and we at least have point at 0 and another point at 8. So what do you do now? You have to, knowing that the height descent occurs at the constant rate, so let's find the rate of change by using the last point and the first point. So the time difference between 0 and 8 obviously is 8 seconds. The time and the altitude, so you go 218 minus 250. So this is because you're decreasing. So you do the last minus the first, and then you get negative reading, negative 32 kilometers over the course of 8 seconds. So you divide 32 by 8, and you get negative 4 kilometers per second. So in science, you would not say the object is moving at negative 4 kilometers per second because you would provide positive number describing the speed, but the negative sign actually talks about the direction where this object is going. So the object, let's say it's returning back to the earth, so it's descending, so the speed shows with negative sign in mathematics. Then we build the first difference. So we have to have established the second column, and understanding that the first column, the time values are constantly changing by the same amount, by 1 second at the time. We do the second entry minus the first entry. So 246 minus 250, boom, -4. Then you proceed to the next difference again, as you can see, and again and again, until the last difference, -4. So they are identical. So this is the first thing that you want to observe. The pattern reveals constant change. And it does make sense, because in the question they said the descent occurs at the constant speed, constant rate. So there you go. The points that if you were to plot those points on the graph, they would have to form a straight line. Now, the direction in this case is negative. That does not negate that the function is linear, that the pattern is linear. As long as the first differences are constant, positive or negative, the change is forming a straight line pattern. It's linear. The negative sign defines the direction. As you're learning about linear functions slowly, bit by bit, there is a concept of slope that will be introduced next video. And then the line may behave like this in case of the positive rate of change, or the line will go into opposite direction when the slope is negative, when the rate of change is negative, when the constant differences are negative. So hopefully this makes sense now. This is the beautiful sort of a summary when you see things on the graph. So thanks to Desmos, given point at 0 seconds, the height is 250. At 8 seconds, the height is 218. And what you observe when you plot the data, that there's a pattern that it steeps down. So the points are going down, down, down. So as you measure the time difference, 1 minus 0, you see the decline. So the rise, the concept of rise or run will be introduced a little bit later, but you have the drop. Each time you go, you drop. Again, you drop. So you, like as if you were going downstairs. So the slope, the direction of the change is negative. So everything makes sense. Later, you will be learning about rise over run ratio to identify the direction of the line. And that's going to be revealed in the next videos. Now, before we go, practice questions. You don't want to be lazy and say, I kind of know it. You want to make sure that you do know it. So do these questions right now before you go away. Share this video with friends. Talk to you later. Bye for now.